All right, good morning, everybody. Randy, just want to start by thanking you for inviting this presentation in front of this group. One clarification, this is monitoring we hope to do, not that we will be doing. So this is a proposal that we're currently searching for funding to support. But this group has come together and identified some of the top priority information needs that have been listed in state dam removal, state and federal dam removal plans. And so one of the big strengths that this project brings to the table is that partnership aspect. And, you know, here's some of the logos of some of the individuals that are part of the work group that has brought this study together and thought through the details of how it would be implemented. And rather than listening to me banter for the next 20 minutes straight, I've brought together some of the members of the work group to talk about their components of this. Everybody has different specialties and aspects that they bring to this project, and all the partners could be presenting in this forum, but we just have a few examples. We only have 20 minutes, so we only have a few examples of that, and that'll include Keith Denton, who will be talking about Sonar, Nick Sohm, and Cyril Mitchell. So they'll be joining me through this talk, and we're kind of doing like kind of a team talk here. So hang in there, and here we'll take some steps here. So, you know, one of the big questions we have here is, you know, what type of response will our fish have from dam removal? Here we are opening up over 400 miles. I mean, what an exciting time. What an exciting time. By the time next fall run hit the Klamath, they're going to be going right up past this spot that you see here, which is Iron Gate Dam. It's this ominous place that has been the end of anadromedy for what, 60 plus years. And suddenly our fish will be zipping right past that. But how many are going to be going by? What species? Here we've got that image you shared earlier, Randy, in the bottom left. Copco 2 removed. There was a celebration going around the environmental community from that image that was shared. But, you know, one thing I want to bring up is that we have great monitoring in the Klamath right now for stock assessment and population monitoring. However, those tools are designed around having Iron Gate in place, right? And so once Iron Gate is gone, those tools are not necessarily effective for capturing population status and trends through time. And we may see new run timings, new run types showing up that wouldn't be captured in our current monitoring as well. So there's also skeptics out there in terms of what benefit dam removal will actually have, right? I'm not one of them, but they're out there. And so we need to have our ducks in a row, have the information to be able to tell this story of kind of basically return on investment for this dam removal effort. So we've developed a effectiveness monitoring tool set, is what I'll call it, to address some very simple questions, right? How many fish pass beyond Iron Gate Dam, right? Like basic question here, but very important to evaluating the effectiveness of this historic restoration effort. Can we refine this tool set? You know, we're going to be adapting this from other river systems, and you'll be hearing that through this presentation. And then how does that repopulation occur? And when we came up with the approach to evaluate these questions, we brought in local expertise through the partners we have, but also looked regionally and also West Coast wide to bring in different methods and techniques to address these questions. For example, we had information from the Smith, the Eel, and the Sacramento rivers, as well as that, you know, dam removal on the Elwha. So we're bringing in information from other major river systems, other dam removal efforts to inform what we're doing here. And here is a map of the basic study design that brings together sonar, which will be used to count fish going by, and then radio telemetry, which will be used to track their repopulation of the upper basin. And this is a map of the distribution of the proposed sites for each, and associated with the dam removals, dams that won't be removed, and dams with fish ladders, and how that may all affect the repopulation. So with that, I'm going to hand it over to Keith. Keith, are you on the line?
Yeah, can folks hear me?
Why don't you take it from here, bud?
Yeah, okay, great. Thanks, Damon. And yeah, thank you everybody for including me in your meeting. My name is Keith Denton. I've been leading the salmon enumeration project on the Elwha for the last 15 years, including working with Sonar and other projects across the Pacific Northwest. So I just kind of wanted to give a little folks an idea of sort of how we're using this monitor on the Elwha, and I think it would be pretty similar analog to what would happen on the Klamath. So I'll just kind of work. I just have two slides. I'll start in the upper left-hand corner and go around clockwise. So the upper left-hand corner, that's a multi-beam imaging sonar. It's about the size of a shoebox. A lot of folks have probably heard about them before. They collect sort of movie-like imagery from a cross section of the river. So then right below that is a top view of this is a cartoon, obviously. There's 96 individual beams, and as the fish sort of swims through, it looks like movie-like imagery. It's in the upper right-hand corner, you see that. It doesn't look great when the fish aren't actually moving, but in the upper kind of 2/3 of that imagery, you can see two Chinook salmon moving by. It works really well in turbid waters, kind of moving down the lower right-hand corner of this image. This is one of the installations we've had over the years in the Elwha. This was closer to dam removal in the Elwha when the turbidity was pretty high. You could see across the river, no problem. And it's just deployed on a simple ladder mount. So that ladder has a pole mount that can adjust the sonar, and then it's actually in the water hanging off of the mount on the ladder. And then downstream is a PVC picket weir used to kind of move the fish out in front of the sonar. I mean, I like to think of it as sort of a flashlight of sound, continually recording movie-like imagery of fish swimming by. One drawback, it doesn't know what species are swimming by. So in addition to sort of operating the sonar during periods of fish migration, we also do this weekly net sampling over here in the bottom left-hand corner, where we use a tangle net that just kind of grabs fish by the jaw, hopefully not by the gills. And then we get sort of what species it is, how long it is, a length measurement, and then we can sort of apportion raw passage on, what a weekly or a bi-weekly basis, however often we're doing the net sampling, to species-specific passage. So we have this raw passage that the sonar counts, and then we make it species-specific with this net sampling. The other really nice thing about the net sampling is it's an opportunity for fish in hand. So for instance, on the Elwha, there was radio tagging project, which is what we'll talk about in a little bit. So there's fish in hand for radio tagging. There's fish in hand for mark rates to assess sort of which fish are going up, hatchery or wild fish. We can get DNA from them, scale samples. So it sort of provides this sort of catalyst for all sorts of other projects with fish in hand. So that's sort of a method slide. And then if you don't mind moving forward, Damon, the next slide is a bunch of data slides from the Elwha. I don't want to get too deep into the details here. This just kind of give an idea of the sort of the data that we're collecting on the Elwha that I think would be pretty typical of what kind of data you could expect to show up from a similar project on the Klamath. So again, starting in the upper left-hand corner, this would be the species composition. So on the bottom axis, there is date, and then on the vertical axis, we have numbers of fish. And then I don't want to overwhelm people with the data here, but you can just sort of see in the white bars is steelhead, the black bars are Chinook, all the other colors are different species. So as you move through time, you have the winter steelhead run kind of bleeds into the Chinook run with these other species mixed in. And you can use that underlying data to take the raw data the passage data from the sonar, and transform it into species-specific passage. So moving over to the right, in the upper right-hand corner, then you end up, this is just an example of 1 year of steelhead data, kind of starting from initial deployment mid-January all the way through sort of early June, and you get the number of steelhead swimming by every day. And we have some statistical models that allow us to wrap in some known sources of uncertainty, such as observer error, the species composition correction. So you end up with very detailed passage data tied to specific species. And then you move into the lower right-hand corner, and this is sort of the range of the project for steelhead on the Elwha. Every year you get to put another spot on the graph, and you start getting these annual population trends that you can start answering these long-term questions. Well, how was dam removal? What is happening with the salmon populations through time? And then because of the net sampling that tells us sort of the start and the end of the run, and also every fish swimming by has a timestamp down to the second on it, you get these run timing graphs. So this is sort of every year that up to 2021 on the Elwha. And it just long lines encompass the total run, and then the thicker black lines in the middle is the middle 50% of the run, with a black dot indicating the middle, the 50% move of the run timing. So not only do you get daily passage, which then you can kind of make annual population trend graphs, but you also get run timing, which, opening up new upstream habitat. I can think particularly for Chinook, you'll probably, hopefully it'll be more spring run Chinook, and you would start to notice these run timing changes. So just kind of in conclusion, you're sort of monitoring a cross section of the river 24/7 with this associated net sampling to get species specific passage, which also gives you run timing and a way to get your hands on fish for a variety of other projects. And yeah, that's what I have. Thank you.
Yeah, good morning, everybody. Thanks, Damon and Keith. So Nick Som here in my new office, about 1.5 miles away from my old office. So I came to be a part of this group when I was working with Fish and Wildlife Service, thinking about extending, the information we're getting from our adult surveys. And it was just really fun this morning, even during Randy's kind of introduction, thinking about, we're talking about active monitoring for dams out on the Klamath. These aren't like far out dreams. We're actually talking about this for real, which is pretty cool. And so, yeah, as I've transitioned here over to USGS and the California Cooperative Fish and Wildlife Research Unit, thinking about how we can take the information we're getting from these cool monitoring programs and maybe extend it a little bit. Damon, if you could move it forward, please. Yeah, so we just had a really nice, succinct intro there. The sonar itself is passive, right? Fish are swimming by. Maybe we're encouraging them to move in a little different part of the river, but we're not handling all these fish. And they take kind of snippets of the sonar footage and expand it based on just the amount of time that's actually used to make counts to get those abundance estimates. And again, that's still passive. But as you saw, the current methods to get species and even maybe age class, like jack proportion, things like that, require us to capture these fish. And that's often the fish nets that we saw, or up in Alaska, they use fish wheels also. But these come with some of their own problems. Fish can get harmed. Potentially, they can be prone to size or species bias. But they're also a great way to capture fish, so there's this kind of trade-off. And so I don't have much specifics to say today, other than we've really got an eye looking forward on how can we take a sonar project and improve the ways we get information from the sonar. Can we use eDNA techniques to help with some of these common questions that we've been getting at? Are there other ways that we can modify and improve the way that the whole study is implemented to just make better tools and refine the information we get? And one of those, we're going to hear about next is taking advantage of the way that we are capturing these fish. So I'll pass it to Cyril.
Hi, yeah, my name is Cyril Michel. I work for UC Santa Cruz in close affiliation with the NOAA Southwest Fisheries Science Center Lab, also in Santa Cruz. I'm the team leader for the UC Santa Cruz Salmon Telemetry team. We mostly focus on Central Valley telemetry studies, but starting to branch out. I personally have 16 years of experience in telemetry projects here in the Central Valley. And that little link down there has kind of a website with a lot of our past and current telemetry projects if everyone wants to kind of look at what we're doing in the Central Valley. It's pretty nifty. We've started to implement real-time receivers so that we can detect fish in real time and post the results online. And there's potential that we could do that for work in the Klamath as well, and it kind of be a fun outreach opportunity to allow people, the public in general, to track fish in real time past these dams. So if you could go to the next slide, please. Yeah, so in general, you know, the radio telemetry proposal that we're putting forward has a bunch of sites that Damon already kind of pointed out that really start near the first dam removal site. And the proposal would be to put a bunch of stationary receiver sites at these red dots. And then in addition, we will have some mobile tracks. So we'll have either car or airplane mounted radio receivers that do systematic tracks through the system to kind of re-site where fish are, especially when they're between these stationary receiver sites, so we can gain more information on their status, if they're still alive, if they're still moving, etc. And ultimately, we want to use both passive and active tracking to answer kind of these questions that we've outlined together as a group. The first one being, can salmonids pass upstream of former dam sites, as well as pass successfully through current fishways, reservoirs, and major canyons. In addition, we want to find out and measure what environmental conditions these fish are experiencing during their migration, and how are they responding to them. We also want to figure out if salmon preferentially migrate to and spawn in specific tributaries, areas, or regions. So we have chosen some of the receiver sites to be near the confluence or literally in major tributaries in these new opened up sections. We also want to know what the upper extent of migrations are, and if it kind of changes through time, if fish kind of move further and further up the system as years go by. We do want to know if there are areas where migration is obstructed and delayed, either through natural areas due to rapids or due to fishways further upstream. And finally, we want to see if there is evidence of any pre-spawn mortality, and if so, where and under what environmental conditions. So those are the main questions that moving forward will be kind of governing our study design and analysis techniques. So that's what I've got.
All right, well, thanks for that, team. This is our last slide. I just want to recognize that the information that we learn from the Klamath is not only valuable for the Klamath, but for other dam removals throughout California and throughout the world. And so I think that's a lot. That's something for this entire group, not just this project, but all of our monitoring work collectively. We should be thinking about how this propels our other dam removals forward throughout for other projects, right? And at CalTrout, we've identified 6 different sets of dams to be removed. That was what we call deadbeat dams. And so we're targeting these. And so we're hoping this information will help us learn from the Klamath, from what we're doing to help propel these other efforts forward to accelerate dam removal and open more habitat across California. This image that you've seen in the back is some of our Scott River Chinook salmon migrating up. Anyway, with that, I'll take any questions if we have time for that.
Damon, can you hear us?
Yes, absolutely.
Great. All right. So we don't need to pass a microphone around in the room because the microphones are so good. They're so good, in fact, that they'll hear your conversations if you're having side conversations. So appreciate your quietness when it's appropriate. One question for you, Damon, is what's the status of the funding? You said it isn't currently funded, but we're getting very close to the dams coming out. So do you have leads? Do you have anything that the folks in this room or online can do to help try to get the word out, or put ask nicely to their organizations that might have some money?
Yeah, thanks for that. We do have a proposal developed that includes the work group members and support needed to get this done. If funded, and we would be able to hit the ground running, but we're planning to get this study on the ground before dam removal next fall, and we're poised for that, but we would need support sooner than later to be able to make that happen. And so if folks have support for monitoring of this type, please reach out. We'd be happy to work with you guys, or we appreciate the support on that. And just from my perspective in now in a nonprofit, is this science and monitoring funds are systemically very difficult to get, even in project this high profile. So anyway, Nick, you have your hand up.
Yeah, Amy in the chat posted a question about AI. So I just wanted to answer that one. So yeah, actually we have thought about AI kind of in my waning time with Fish and Wildlife Service. I was in contact with someone who was communicating with a group working on AI and looking for natural resource applications. And I also know that the LWA group, so Keith et al., are actually pretty far down the road with what sounds like some pretty cool stuff.
Yeah, thanks for that.
Yeah, I
Nick.
can chime in on that real quick. We're working with some folks at Caltech trying to automate it. It's not simple. The person that asked the question in the chat, the link to that paper, that was based on video imagery, which is a lot cleaner and easier to identify than sonar imagery. So while it's certainly things are going that direction, and I think at some point, hopefully the not too distant future, the council get automated, because data review is definitely a huge bottleneck for the sonar. I mean, we're just lucky enough to have a really good person doing it on the LWA. And I think that, you know, in the not too distant future, the computers will be doing it, but we're not quite there yet.
Jacob Crowley from USGS, Environmental Solutions Station. I was curious on how you plan on disentangling wild fish from hatchery-raised fish, and why you specifically cited at the old Iron Gate Dam and not at the future site of the hatchery at Fall Creek.
Yeah, I can respond to that. That's something we're looking at right now. And if folks have ideas of a spot above Fall Creek, that would be amazing. We would love that. But right now, Res has been nice enough to offer a secure and powered location that has good channel form for installing the sonar. And so we've sited it there initially, but would love to move it up above the hatchery if that's if an appropriate site pops up, right? No problem with moving the location if we can figure that out. So and with the hatchery, that, you know, we'll be working off the marks, right, and using that to come up with a hatchery versus wild estimate there. But that's something we've got our eyes on. Thanks for that question.
All right, other questions? Yes.
Been prepared for this a long time, and one of the things that's catching me by surprise is all the deference to the rafting community and infrastructure and access that is river modifications. Is there any thought to monitoring the impacts of that recreational activity on recovering fisheries?
The impact of rafting on fisheries?
And the infrastructure that they're building, channel.
Yeah, I don't know if you know, I'm the best person to address that question. That's a good one though. Maybe someone else in the audience wants to jump on that.
The only infrastructure I'm aware of is river accesses. My partner works for American Whitewater, is involved in that. I haven't heard anything about channel modifications. Other than the removal of trees, other than the removal of trees in Ward's Canyon.
Jetties, all kinds of stuff.
I haven't heard anything like that.
Damon, I know it's, you know, outside of the project you're presenting on, but from a fisheries monitoring perspective, if your project doesn't get funded, do you know kind of in general what's going to be done for monitoring that is funded for fisheries?
So there are some other monitoring that is being supported, and is Crystal in the audience? Or Crystal or Kurt might be able to talk to. CDFW does have some monitoring that's going to be going, and I think US Fish and Wildlife Service is going to continue with their downstream rotary screw trapping operations and some of their red surveys. I believe, which will actually be really complementary to this effort to have like out migrants and adults. That's like just a great pairing. Nick, do you want to jump on that?
Yeah, I'll just add that Fish and Wildlife Service is funding an expansion of the red surveys. It's kind of two phases. So this is in collaboration with the Karuk Tribe. So spatially between where Copco is and Iron Gate is, and then also state line to where Iron Gate is. So there's a commitment to that work.
Okay.
And Fish and Wildlife Service is committed to maintain the spatial resolution of its current adult monitoring. And I see some Fish and Wildlife Service folks who are on who might also want to speak to that.
For the watershed program, California Fish and Wildlife Service. So we do have funding to do productivity, so out migrant traps on the tributaries in that new area from Iron Gate to state line. And then we'll also be doing the adult surveys in the fall, so the abundant assessment.
And just to tag on to what Crystal just said, those tributary surveys are going to be complementary as well with this effort, right? And so there's some talk of adding pit tags to some of the fish too, to see, you know, their behavior in the tributaries. And so this project's focused really on mainstem recolonization or repopulation, and then the, you know, complementary effort is from the state on the tributaries. So anyway, you know, these things work hand in hand.
Any other questions? All right. Well, Damon, thank you so much for organizing that. And thanks to all the people who had a role in that, in those slides.
Yeah, thank you, Randy, and everyone else.